Good evening, my dear students and dear parents who are watching this program. NTV's My Teacher, the live classroom of the UAE. So after a break, after vacation, today we are going to have a live session of physics for grade 12. So I hope all of you are joining me. If you have any issues in connection with the physics contents of grade 12, you can feel free to call me right now. So it's a live program, and we were having these classes even before the vacation. We had discussed a few contents even for grade 11, and after the 2 months vacation, I think almost all of you might be now geared up with the preparations for the examinations. In some schools already examinations for the first book of or first part of the textbook already started. And some other schools, the exams are going to be there in the next month. So whatever is the case, you watch this class today, and today my plan is to discuss a few questions related to the board examinations, which we are going to that is related to board exams, or which all questions were asked in the board exam. We are going to discuss that. After that, we will see some of the sample paper questions as well. So I'll show you the question and I will solve the questions on the board. And before going to different questions, I'll explain a few concepts coming in the last or second last chapter of the first book. That is very important for the examination. So that portion I will just brief you about a little bit, then we will get back to, or we will come back to the questions. Okay, so that we will see. So now the thing which we want to, I want you to get into is the concepts of alternating currents. So by now almost all of you must be aware of the fact that the chapters coming in the first book are very much interlinked one after the other. That is about basically relating electricity and magnetism. So if you look at those contents in sequence, you can make out one thing in the grade 12. First we started with static electricity, charges at rest. Then the next unit we started thinking of moving electricity, that is current electricity. Then we studied the effects of current, that is magnetic effects in particular. Then about magnetism and matter, Earth's magnetism we discussed. In fact, after that what comes is we are thinking of production of electricity, that is by electromagnetic induction. When we produced electricity, we have seen there are two types of current or electricity, namely DC and AC. So the properties of AC we are discussing in the chapter alternating current circuits. So by those who have done this chapter in the school, I think almost all of you might have completed this chapter in the school. So by this time you must be aware of the fact that there are many mathematical applications coming in the chapter alternating current circuits. So in that matter, I would like to tell you 2 points. First is, you be very familiar with the textbook questions from these chapters, which are really relevant as far as the board examination is concerned. So you should give maximum priority to the textbook questions and previous year's questions. And one more thing I want to tell you is the recent question papers, that is the question papers of 2015 CBSE board examinations. It's already available in the CBSE's website. So all of you may refer those. And in fact this time it's all the regions examination papers, and along with the marking scheme. It is really an important document as far as the preparations for the board examinations are concerned, because you will come to know what is the expected answer for a particular question, and you can verify your answers with what is supposed to be there in as per the CBSE's guidelines. So you will be able to make out where exactly you are going wrong, and is there any extra thing you are writing in your answer, which is maybe you will be writing for 2 mark questions, you may write maybe so much. but that may not be required. What are the essential points which are supposed to be there, and any points missed in your answer, or any points, which all points are excess in your answer, all these you can make out by referring the marking scheme. So each region's question paper and marking scheme you can download and take it as a practice. Remember, the time which you are getting just before the board examination will not be sufficient for going through all these papers. This is the right time for you to cover up those questions as well along with your preparations. With that note, let me explain a few concepts from the chapter alternating current circuits. After that, we will come back to the questions. So today, once again, let me tell you, I will explain a concept or a few concepts related to AC. After that, we will discuss the sum of the board paper questions and the sample paper questions. We will say according to the availability of time. But more importantly, if you have any confusions, any doubts, and it is there with you, remember it is a live class today, it is not a recorded lesson, it is a live class. So today is Monday, right, 28th of September, right. If you can, if you have any confusions related to the contents we are preparing, or if any questions you have in store, you can very well call us right now, so that in between, along with the classes, I will be able to clear your doubts as well. So make use of the time, make use of the classes, and with that note, let's go ahead, right. So stay tuned and let's see. See, I want this to be explained today, that is the concept of what you call as resonance. Resonance is a very important aspect as far as the alternating current circuit is concerned. So the resonance further means, so the concept you studied in grade 11, there also we have seen a concept of resonance. There are two things in 11th standard. What you studied about resonance, you have, you might have studied about the sonometer, resonance column experiments and all. So there we are making use of concept of resonance. If something is vibrating with a given frequency, and that is its natural frequency, whereas that is what is making another object to vibrate, that is forced frequency, with the same frequency. If the frequencies are matching, we can say they are at resonance. You know what's the peculiarity at resonance? At resonance, it will become it will give out maximum amplitude. Amplitude will be very large. This is what we have seen in 11th standard. In fact, same concept is what is applied here as well, but here the case is that we have an LC circuit, inductor capacitor circuit. Inductor capacitor circuit. Okay, so this circuit, when capacitor is charged and disconnect from the battery, further connected to inductor, it will produce electrical oscillations. These electrical oscillations are given by a frequency nu is equal to 1 by 2 pi root of LC. We have studied this, right. So once again, if we have a charged capacitor, the charged capacitor is disconnected from the battery and connect across inductor, it is what is forming an LC circuit. This kind of an LC circuit will produce electrical oscillations of this frequency. Okay, so this is the natural frequency provided from the circuit. Suppose we are providing AC. Now we have an LC circuit. Okay, again. So to the LC circuit, we are supplying a voltage. Okay, in an LC circuit, if we are providing a voltage, and that voltage is also of frequency 1 by 2 pi root of LC, then what happens? We are supplying a voltage, AC voltage is supplied to the circuit, right. We are providing a circuit, providing an AC voltage to the circuit, and that is also of the same frequency as that of the frequency of LC circuit. We say it is at resonance. So we call that as therefore the resonant frequency, nu R. So when I write nu R is equal to 1 by 2 pi root of LC, it means this is the frequency which we are supplying to the circuit. AC voltage is supplied with this frequency, which is the same as its own natural frequency. So what happens is it is becoming at resonance. This is the condition for resonance, right. At resonance, the frequency of the circuit and the frequency of the applied voltage are the same, right. Then what will happen? If it is so, the current would be maximum. If you plot a graph, you must be familiar with this graph, the current frequency graph. If you plot, you will see that it will give maximum value, right, at this particular frequency, resonant angular frequency. 1 by omega R is 1 by root of LC, the same thing. One is angular frequency, the other one is linear frequency. Remember, when you write these two quantities, in most of the cases it may be just simply mentioned as frequency. So it may be angular frequency or a linear frequency, but from the unit you can make out angular frequency is in radians per second and linear frequency is in hertz. Okay, all right. So we see that there is maximum current at this particular frequency. Similarly, the power also, right? Power frequency graph also, if you plot, you will see the same thing, that is, see the variation is same. So what you make out is, at resonant frequency power is maximum, at resonance frequency itself the current also is maximum. So see the amplitude of current or the power that become maximum at resonant frequency. This is what exactly studied in 11th grade as well. Natural frequency and forced applied frequency, both same, means resonance, resonance means maximum amplitude. So this is the concept of resonance. So in short, if a circuit is supplied a frequency 1 by 2 pi root of LC hertz, it means that circuit will give out maximum power and that circuit will give you maximum current as well. This is the concept of resonance, right? Now at resonance what all changes happen? You know the term which we have in AC circuits, you know in current electricity the term we have for the opposition of current is simply the resistance of the circuit only, resistance only, right? The resistance is the only opposition in DC circuits in general. Whereas in AC circuit, in addition to resistance, another term we have, that is reactance. Okay, instead of resistance we have reactance. Reactance is what is offered by inductor and capacitor. So inductor reactance is what? XL is equal to omega L, and capacitive reactance is, inductor offers a reactance opposition given by omega L and X is 1 by omega C. So and now suppose we have an LCR circuit, inductor, capacitor, resistor, if all the three are there, then what will be the picture? It will have opposition offered by all the three components, right? All the three components opposition means inductor is opposing, that is reactance, capacitor is opposing, that is also reactance, and resistor is opposing, that is resistance, right? All the three together there in an LCR circuit, all together is what is represented by the letter Z, that is called impedance, right? So this is impedance. So let us take it in this way. The opposition offered by resistor is resistance, opposition offered by capacitor or inductor, that is reactance. So we have two types of reactance, namely inductive reactance and capacitive reactance, right? Inductive and capacitive reactances. Now the importance is that reactance offers opposition but no power loss, there is no any power loss, whereas resistance when offers opposition there is a physical opposition. You understood? Always you think of this example, like suppose if you want to stop a person, okay, that fellow should you don't want that fellow to come to you, okay, so what you can say, don't come. If you come like that, if he is listening to you, you are not losing any energy, right? Purpose is to stop him. But if he is forcefully, if he is trying to come to you, you have to apply force, right? We have to spend energy. There again the purpose is the same, to stop him. So there is a physical opposition, that is resistance, correct? Whereas non-resistive opposition, non-physical opposition is what is reactance, okay, reactance and resistance. But in an LCR circuit, what is the situation? Generally in AC circuits there may be resistance and reactance both together. So all together is what is termed by the term reactance, impedance. So impedance is the overall opposition or total opposition to the flow of current in AC circuit, including resistance and reactances. So it's given by another equation you may make out from this. This also is the equation, it's very important equation, XL minus XC the whole square. So impedance is equal to root of R squared plus XL minus XC the whole square. That is the expression for impedance, that is overall opposition, okay. Now let me tell you what happens at resonance. So the basic, sometimes the question will be there, distinguish between resistance and reactance. Resistance is the physical opposition offered by the by a resistor in a circuit, whereas reactance is the non-resistive opposition or non-physical opposition offered by maybe inductor or capacitor connected in AC circuit. But what happens is, in or at resonance in an LCR circuit, so I told you at the beginning, we are going to discuss the situation on resonance. Okay, at resonance, what all changes happen in a circuit? Listen carefully. The very first thing is, the inductive and capacitive reactance will become equal. That's the first thing. The change is happening at resonance. Okay, at resonance, XL is equal to XC. So what happens from the expression for impedance? You can make out that impedance becomes R. XL and XC cancel off. That is, the circuit will behave purely a resistive circuit. Okay, purely resistive circuit. That is, if the frequency, and what about the frequency? The frequency is this much, 1 by 2 pi root of LC. Okay, and we know that an expression for power factor we have, cos phi is equal to R by Z, that is the expression for power factor. So at resonance, what is happening is R and Z are equal now. So if they are equal, cos phi becomes 1. If cos phi is equal to 1, that is power factor is equal to 1, then phi is equal to 0. That means there is no phase difference between current and voltage. Current and voltage are in phase. Okay, so that is what's the situation. So you can make a note on these are the changes happening in an LCR circuit if it is at resonance. Impedance becomes equal to resistance. And current is maxima, that also you should think of. Current is maximum. What will be the equation for amplitude of current? Just you take Vm by R only. So the very important aspect to understand is, whenever the questions are related to LCR circuit, you just check, by some way, sometimes in the question to be mentioned that the circuit is at resonance. If it is at resonance, to calculate current, you don't need XL and XC. Sometimes capacitance, inductor, everything may be given, right? But you don't take that value. Just voltage divided by resistance gives the normal way, like in current electricity lesson we have studied now. So the same way you calculate current if the circuit is at resonance, because at resonance impedance is just equal to resistance. Okay. Also an expression for maximum power also is maximum, I mentioned about that. Correct? Power also is maximum, which is given by Vm squared by 2R. Okay, so these are the things happening at resonance. Okay. Now one more thing. So resonance is the point explained. Resonance is made use of in some place. You know where it is? Where is the resonance made use of? One thing what you can make out clear is if the frequency supplied to the circuit is equal to 1 by 2 pi root of LC, that is natural frequency of the circuit will be at resonance. If the circuit is at resonance, it will absorb maximum power. Power absorbed by the circuit is maximum at resonance. Okay, that is one thing to know. Okay, this fact is what is made use of in what we call as a tuner. Let's think of a radio tuner. In a radio tuner, this is tuning is what is achieved by the concept of resonance. What exactly tuning means? We have so many radio stations, TV stations and all. These stations, the radio stations are assigned different frequencies. So a particular frequency is what is to be received. We have so many stations, of which one particular station is to be received. So it is tuned to that particular station. So that device in the receiver which selects a specific frequency is what is called tuner. So in a radio tuner, therefore the major component of a radio tuner is an LC circuit only. Right? LC circuit. What kind of capacitor? Capacitor is a variable capacitor. So while tuning, what exactly we are doing is we are changing the value of capacitance of the capacitor. So in a radio tuner, we have an LC circuit. LC circuit with a variable capacitor. Variable capacitor, what are the factors on which capacitance depends? Capacitance value depends on the nature of medium, the area of the plates, then the distance of separation between the plates, all these are the factors. So in a tuner, what is happening is the plates, separation of the plates, there will be like varying separation, varying area between the two plates, or some way or the other there is a provision for changing the capacitance. While tuning the radio, what we do is we are changing the value of capacitance of the capacitor. When you change the value of capacitance of the capacitor at a particular position of the tuner, okay, we are tuning to a particular station, okay, at a particular position of the tuner, the value of capacitance would be such that it will satisfy for a specific frequency in this equation. L has a given value here, okay, at a particular position C also has a given value, C has a given value, L also has a given value. So remember, while tuning we are changing the value of capacitance, but at a given position of the tuner, there is a given value of capacitance. If you substitute that value in this equation, what happens is it satisfies for only a particular frequency in this equation, okay. So which frequency is satisfied in this equation? You see that frequency only is what is received in the circuit, because at resonance power reception is maximum. And also the curve which we use for tuning this circuit has a power frequency curve like this. It will be very sharp resonance curve. Sharp resonance curve means the resonance occurs only at a specific frequency. So what does that mean? Only at that frequency the power reception is maximum. If the frequency is less than that or more than that, in both ways, deviation, lower frequency or higher frequency, in both, the power reception is considerably reduced. So the power reception happens only at a particular frequency with the maximum power. So that frequency only is received. There only we have a significant term to understand, that is called Q factor of the circuit. So what we do is we are keeping the Q factor of the circuit very high. Q factor is represented by, actually Q factor is another term to be clear about at this stage, that is, it is representing the sharpness of the curve. If the Q factor is very high, the curve of the resonance curve is very sharp. If the resonance curve is very sharp, what else we can make out is that it will receive maximum power only for a particular frequency. That's why if the tuner is not that good, it's not that good quality, and if the sharpness is not that high, then what happens is there may be overlapping signals. Where 2-3 stations will overlap and will hear together. Okay, so sharp tuning is required, or if you require a sharp tuning, the circuit has to have a very high Q factor. So Q factor further depends on what? This is the equation for Q factor. It depends on the values of resistance, inductance and capacitance. So today I just mentioned the situation or the case of resonance, okay, how resonance is made use of in radio tuner, how radio tuner functions. Tuning is the setting up of for a particular frequency of a given station. Suppose we are tuning to another position, so turn the tuner to another position. At that position the value of capacitance is such that it satisfies for another frequency in this equation, and that frequency would be received with maximum power in the circuit. So that program we will hear. And remember, at the beginning itself we should make sure the values of these are adjusted in such a way that the value of Q is very high, so that the sharpness of the curve is very high. So only a particular frequency is received. Okay, this is one type of concept. Now we will discuss a few questions related to this, because all of you are in the stream of busy preparations for the examinations. And so at this stage, rather than explaining many concepts, instead I told you at the beginning of the session, if you have any confusions of any topics, you can very well call me. Okay, you can right now you call and find out if you have any any doubts. If you have, you can find out the answer to that. Okay, we will try to figure it out. Okay, and at the same time we will discuss a few questions related to this chapter, or in generally which are required for the first term exam. And from this chapter I will explain one question. Okay, listen carefully. Again we are talking about LCR circuit. Okay, I am just giving you an idea about another question. The potential differences across resistor, inductor and capacitor, the values are given. Okay, so in an LCR circuit, the potential difference or voltage across inductor, let us say it is given to be 80 volts. Okay. Resistor, let us say it is given to be 60 volt. Okay. Whereas capacitor, it is given to be 120 volt. Yeah. One second, 160 volt, let us say. Yeah. So, the voltages across capacitor, inductor, resistor values are given. Inductor 80 volts, resistor 60 volt and capacitor 160 volt, let us say 160 volt. So, these values are given. You know, these are the voltages across these components when these components are connected. LCR circuit is connected to an AC source of say 100 volt 50 hertz supply. This is one question. 100 volt 50 hertz supply. If this is the supply voltage, these are the voltages across the three components. So, the question is, when you add these voltages, will the sum of the or will the total voltage be greater than the source voltage? Okay, so that means if you add them, how much you get? 80 plus 60, 140, 140 plus 160. So, it will become 300 volt, right. So, total voltage is going to be 300 volt, but you know it is much greater than 100 volt. The source voltage is 100 volt only. Source voltage is 100 volt, but when you add these three, we are getting it much higher than that. How will you resolve the paradox? You know, this it's actually a problem. Why? Because you know source voltage is only 100 volt. Total voltage that we are supplying is 100 volt. That should be divided among the components. But what do you see here? It's like across each component the voltages are like this, so that when we are adding it, we are getting them, we are getting a value which is higher than the source voltage, which is not accepted. So, how will you solve this issue? Otherwise, what is the reason for this? So, the basic reason is that you know there is a phase difference concept between the voltages. This is across VR, across VL and across VC. The voltages have a phase difference 90 degree. Between VR, VL there is 90 degree, VR, VC there is 90 degree phase differences. Between VL and VC there is a phase difference of 180 degree or pi radians. Okay. So, total voltage to find, you cannot go for algebraic sum, we cannot go for the normal addition, instead we should go for vector addition. Vector addition concept, when you apply, what you get is VR squared plus VL minus VC the whole square. This is how we have to find the total voltage. So, you just see how will you find the total voltage? VR squared, which is 60 squared plus 160 minus 80, right, that is 80 squared. 60 squared minus 80, 60 squared plus 80 squared root is what? 100. See, it is solved. Total voltage is 100 volt. This is the one. This is one important question for the exam. That is, we have the individual voltages given, and when you add, the voltage becomes greater than the source voltage, which was 100 volt. Okay, but it happens because normal addition of voltages is not true in the case of AC circuits. And what kind of addition is expected in AC circuits? Vector addition. Because it is vector addition, we have again what you say, root of VR square plus, that is parallelogram only is what is applied here, root of VR square plus VL minus VC the whole square. So, we are getting 100 volt. Hope all of you understood this point. Now, more questions we will discuss after a very short break. Now, I am going for a short break. After that, we will come back and we will discuss more questions on AC. By the time, still if you have any confusions, you collect them and be ready for that, and we will discuss more questions after a short break. Stay tuned.